Welcome to the last video in the series where we're going to talk about the evaluation. And again, as before, heavy use of ideas and drafting from other sources. So here's the evaluation challenge. We want to develop a set of metrics that says how well did our approach work. We created these buckets. And I'm going to specifically talk about topic modeling as an example, but with any kind of text analysis, we're going to say this is about economics, or this is about sociology, or this is about astrophysics. Alternatively, we could say this is about who's going to win the election, or who's going to how much people like or dislike something. We've got to characterize it. We've got to call it and say it's in this particular bucket. So the challenge is that typically we're not sure exactly of the bucket that we put the things into. We've essentially created a score between 0 and 1. Those of you who are used to using statistics, if you've used logistic regression, there's a continuum. It's very rare, in fact, obviously by the design of the logistic regression, you never have exactly a score of 1. It's asymptotically going to approach 1 or 0. So what we're going to have to do is we're going to have to say, you know, anything above a certain score, I'm going to say is in a particular bucket. It is about economics. Or, for example, in paper 3, it is about administrative data. So anytime we do that, we are essentially saying that we are saying, yes, this is about topic X, or no, it is not about topic X. So what we want to do in the evaluation is to figure out how close we are to being correct. The challenge is that being correct, what is often referred to as the ground truth, can, particularly in the case of text, be subjective. So for example, when I look at an article and I say this is about, let me say, orange carrots, someone else might look at it and say, no, it's about orange carrots with green stripes. So you can get a lot of disagreement, even among subject matter experts, about whether or not something is correct. So bearing that in mind, our key notion is if we agree on a ground truth corpus and we say, okay, I have had a whole bunch of experts go through and classify the topics and say we have reached consensus that this document is about X. Now I'm going to run my model and predict whether the document is in fact identifying it as in topic X. So now what you have is, just like with any machine learning approach or any classification problem, now what I want to do is I want to see how often do I get a true positive, how often do I get a false negative, how often do I get a false positive, and how often do I get a true negative. And obviously, the higher I set the threshold, the more certain I am that every single one that I say is in bucket X is going to be correct. But then I'm also going to, at the same time, the higher I set the threshold, the less likely I am to correctly get the negatives. Let me give you a specific example. So suppose that I set the threshold of saying that something is about economics at a very high level. Then I can be pretty sure that every single paper that I got that I said is an economics paper is in fact about economics, or if I'm talking about child abuse or whatever topic it is. But by setting that threshold so high, I have, by definition, missed a whole bunch of papers that were about economics or that were about child abuse, and I've missed those. So by being so focused on always being right, I missed a whole lot of papers that I should have caught in my fishing net. And so that's a whole bunch of the, I have missed the papers that I should have got. So that confusion matrix that you see again here is summarizing that set of errors. So we can talk about 4 different measures, and these are the measures that we're always going to look at: accuracy, precision, recall, and specificity. So people like to talk about accuracy a lot as if that were the gold standard. It depends on, obviously, the loss function. This is talked a lot about, obviously, in the machine learning literature, so I'm not going to berate it here. But you may want to, as I said before, always want to be precise, that if I say it's a true positive, I'm getting a very high proportion of the ones that are actually, when I say it's positive, I'm right on the money. That's different from saying true positive versus true negative. Or the recall is saying, of all the documents that I say are true positive, I am getting a very high proportion of the true positives versus the class of documents where I'm including in the false negatives in my denominator. So another way of writing this is to say, the precision is to say, I have of all the retrieved documents, so how many of those are relevant as a proportion of all of the documents I'm looking at. So that's what we're used to thinking of as type 2 error. And recall corresponds to the type 1 error that we're used to looking at. So the computer scientists are just using 2 different terms that we as social scientists are used to thinking of as type 2 and type 1. If you want to go and take a look at a cheat sheet, I don't often refer to Wikipedia as kind of a useful document to go to, but there are many, many different approaches that you can use to look at, depending on what you care about, your predictive value, your false discovery rate, your false emission rate. There are many, many flavors, and there are, obviously you can weight all those depending on what your loss function is. So again, I'm not going to spend too much time on this, but I just wanted to highlight the fact that there are many, many different metrics that you can use. So of course, the challenge is how do I find ground truth? Because what I'm really interested in is finding how often am I correct, either at getting the buckets correctly labeled, or as getting rid of the ones that are incorrectly labeled. So Jordan has a very nice example here in where Jordan Boyd-Graber has this very nice example here where you have tagged a document group as computer science, biological science, and physics. Now, what people often use, and we talk about this in the food safety book as well as a little bit in the Klichikin and Boyd-Graber book, one way in which you can figure out what ground truth is you can compare it to Wikipedia, which is a human-curated corpus of describing what computer science is, what biology is, and what physics is. And in fact, that's what we use for the food safety work. We looked at the words that experts gave us, compared it to the food safety section of Wikipedia, and then did a document comparison between the abstracts and how often the set of words showed up in the Wikipedia page. So what you can do is you can say, let's say that Wikipedia is ground truth, and then what we're going to do is we're going to compare what we bucketed on computer science or food safety, and then compare it with the actual amount. So, for example, you can then say, if I take the Wikipedia page on computer science, say that that's ground truth, then, and I only find 40% of the documents as a result of using that measure, then my precision is 40%. And then recall is 60%. You can see how there's that direct trade-off between precision versus recall, because I know that 60% of those documents were actually computer science and I wasn't able to capture them. So that trade-off between precision and recall is foundational. Let me give you an example of how we did this with the food safety project. What we did was we took each abstract and we asked experts to say, here's the food safety, here's an abstract, tell me whether that's food safety or not food safety. And that enabled us to develop a corpus of what we hoped was correctly classified food safety examples. Now, if you think about that, Facebook does this all the time, where they're trying to get you to say, this is my friend, do I have their name right? You click on it to say, yes, that is their name. What they're doing is they're building a better machine learning algorithm or a topic modeling classification system to improve their internal models. Got a whole bunch of useful scripts and information that you could go and look at. There are some very good lectures that go into this in more detail than I can. I'm a huge fan of Jordan Boyd Graber's work, so by all means go and take a look at his website, and you can also go and see the examples that Raid provides. Again, please go ahead and look at the examples or the questions on the website and answer them before we have our in-person meeting. Thank you very much.